Howdy. Max of the way. Max of the way to go. I suppose I don't see more Max out there. Okay, hi guys, let's get started. Apologies for the bit of the slow start. This is my first lecture for the semester. I'm guessing it's your first lecture for the semester too, so I'm still sorting out my technology. For those of you who've met me before, hi, welcome back. For those of you who haven't, my name's Rob Meredith, and I'll be the lecturer for FIT 5095. If you're not here for FIT 5095, well, you know, stick around if you like, but I won't be offended if you leave if you're in the wrong room. For those of you who do remember me from FIT 9003, you remember I tend to lecture with devices in my hands. I'm trying this semester to get it down to one device. So I've got this nifty remote control on my iPhone, and hopefully it's recording audio at the same time. The reason I tend to lecture with the devices in both hands is that for this unit, and my other units as well, I record a podcast of the lectures. Similar to the Mulo podcast, which I'm guessing most of you are familiar with. But I find that the audio that I record and the video that I put together and can snip out the breaks and things like that turns into a better quality podcast for you guys to listen to. So that's why I've got this in my hand, really, is to record that audio. I'm recording the video, and just remember that, you know, if you guys make comments or ask questions in the lecture, you'll probably be picked up by the microphone as well. And the podcast is publicly available, so don't say anything that you'd be embarrassed for your mum to hear or something like that. Anyway. Has everyone got two handouts? There should be lecture notes, the slides, and the unit guide. Now, every week I'll bring this format of the lecture slides printed out to class, so you don't need to print them out yourself. But if you do want a different format of the lecture slides, I've got on Moodle PDF versions of 1 slide per page, 2 slides per page. This is the 3 slides per page, and if you're really into saving through, this is 6 slides per page. So that's there if you want the format, but I will be bringing the 3 slide per page format to class for you. A little bit of value add. You don't pay a fortune to come and listen to me talk, so it's a little bit of value provided for you. What we might do before we kick off the lecture is perhaps just quickly go through the unit guide. Most of you, this is not your first semester. Is there anyone here who's here for the very first time, first lecture, first semester here at Monash? 1 or 2? Okay, just for you guys, every unit you should get one of these unit guides given to you. If not handed out in class, at the very least it's available online through our unit website. So it's important to read each one of these for each of your classes. There's a lot of boilerplate material in here, so the unit guides look fairly similar, but kind of that spiel that you hear when you're on the plane and the stewards are going through, here are the exits here. Each airplane layout is slightly different. Each unit guide is slightly different too. So make sure you read through it. It details basically what we're going to go through in the semester, what we expect of you and what you can expect of us in terms of interaction and feedback and those kinds of things. So let's very quickly just go through the unit guide. The only prerequisite is FIT 9003. Some of you may have got an exemption for FIT 9003. That's the database systems design unit. The rest of you, I'm guessing you passed it, so you should be all right with that. My contact details are on page 2. So if you haven't had me before as a lecturer, my details are there. There's a fax number included there for some reason. We don't have fax as much here at Monash anymore. You can try faxing, but good luck. The phone and email are probably the easiest way to get hold of me. And even though they've included a fax, they haven't included an email address. The standard format of Monash email addresses is just first name dot last name at monash.edu. So my email address is rob.meredith@monash.edu. So feel free to shoot me an email at any time, and I'll try to get back to you as soon as possible. The learning objectives for the unit, I'll talk a little bit more about the nature of the unit, what angle we're taking on data warehousing. It might be a little bit different to what some of you are expecting, so I'll explain the rationale of how we're tackling the unit or the topic. You'll also see at the bottom of page 2 the summary of the assessment items for the unit. So there's 2 assignments overall. The first one's worth 20%, the second one is worth 30%, and then the exam is worth 50%. So not too dissimilar to what a standard graduate would have. Now, in terms of feedback to you guys, we provide feedback obviously on the assignment material. So when you submit an assignment to us, the tutor will mark your assignment. There's also an extra just over there. So the feedback that we give you, obviously on the assignment material, we'll write notes, and give you back a marking guide, things like that, to explain feedback on the assignments. But during the semester, because there's only 2 assignments, they're sort of long time between breaks, it's good to get feedback as you go. And that's a little bit difficult to do in this kind of lecture tutorial setting. You get feedback in the tutorials, but it's difficult to get feedback on how you're learning during the lectures. One of the things that I try to do to tackle that is make extensive use of the online discussion forums. So all units have a unit website, and we make extensive use of the Moodle website for this unit, and that has a discussion forum. And I'd strongly recommend posting questions to the discussion forum. In the past, the online discussion forums have worked really well when there's been you kind of have to cross a certain threshold with the number of posts before it starts to take on a life of its own. If it falls below that threshold, it generally doesn't work during the semester. But when it does go above that threshold, and I don't know what that threshold is, but there's some magical number, the forums take on a life of their own. You get a lot out of it. Students ask questions, I respond. Students respond. It becomes a really good way of getting feedback with how you're learning throughout the semester. So you don't find yourself at the end of the semester ready to sit the exam and go, I just don't understand the material or that sort of stuff. So the earlier you ask questions, the more often you post to the discussion forum, the better a resource it will be for you guys. So myself and the tutors will keep an eye on the discussion forums, we'll respond, but feel free, if you know an answer to a question that someone's asked, feel free to chip in, or if you've got a slight variant on the question, again, feel free to post and respond. In terms of the tutors, we've got one of the tutors here today. One of the other ones might poke their head in a little bit later. Everyone say hi to Felix.
Hi, Felix.
Felix, say hi to everyone. Felix is from Chile. He's a lecturer at the University of Chile. There we go. And he's come over here to Australia to do cross-cultural stuff, but to do his PhD. So Felix is currently studying with us in the Monash University Decision Support Systems Laboratory. There's a few other PhD students. That's a few other PhD students in the laboratory as well, and doing research on issues related to the use of IT with management decision making, business intelligence, and so on. So this unit kind of falls within that realm of business intelligence. It's part of the business intelligence specialisation, and the focus of the unit is very much on using IT, using data to support organisational decision making. There's lots of issues involved with that, and we're going to explore those over the next 12 weeks. Everyone's aware that Monash has now moved to a 12-week semester. Is that a good thing or a bad thing? I'm not sure. It'll be interesting to see how it goes. So over the next 12 weeks, we're going to explore the issue of using data, providing data resources to organisational decision makers. That's largely what the semester's about. You met Felix, he's one of our tutors. Some of you have met Steve Remington before, he's another one of our tutors. Felix specialises, was a lecturer in Chile, specialising in database theory and teaching database design. Steve is a former consultant, specialising in Steve Remington's an ex-consultant who did consulting work in business intelligence and data warehouse design and so on. And we've also got, I think, Andrew has agreed to be a tutor with us as well. So if you've done 903, had Andrew as a tutor, you know what Andrew's like. It's better than I do. But good response, good feedback. He's very enthusiastic and knowledgeable about the area too. Andrew did this unit about 2 or 3 semesters ago and was one of the highest rated, highest scoring students in the class. Okay, the syllabus or the unit schedule is outlined, broken up over pages 3 and 4. It's a long semester, long start to the semester this year. The break's not until week 8. So pace yourselves, guys, if you don't need it. But we do have a fairly long break mid-semester, so at the end of April, the mid-semester break happens between weeks 8 and 9, and because of the Anzac Day holiday and things like that, it's a slightly longer than usual. Don't quote me on that. Anyway, so those are the topics we're going to go through. I reserve the right to slightly amend those topics as the semester goes along, particularly as this is the first time I've done a 12-week semester rather than 13 weeks. I think it'll work out okay, but I may need to shuffle things around if I find that we're not keeping up with what I want to cover. Details of the assessment tasks are on page 4 and 5. As I said, there's 2 assignments. The first one will be a design specification for a data warehouse system. So we're going to teach you an alternative modelling technique to entity relationship diagrams. So everyone's familiar with ER diagrams. You know what an ER diagram is, I hope. That's why we've got 903 as a prerequisite for the unit. We're going to teach you an alternative to that approach, specifically designed for data warehouses and business intelligence systems called dimensional modelling or multi-dimensional modelling. So we'll spend a few weeks at the start of the semester in the lectures and a few weeks in the tutorials practicing that technique, and then you'll use that in an assignment setting to design a data warehouse system yourself. That's assignment number 1, worth 20%. The due date for that is week 8. So you've got a fair bit of time to work on that. It takes about 3 or 4 weeks for us to get up to speed with the dimensional modelling material, and then that gives you another 4 weeks or so to actually do the assignment. So I'll try to get the assignment specification of that out in the next couple of weeks or so that you've got a chance to look over it and get ready. Assignment number 2 is a research paper, so it's a research essay. For some of you that's a fairly daunting kind of task, but we're going to have a tutorial or 2, for those of you who aren't comfortable with essay writing, a tutorial or 2 on how to cite references, how to structure an essay, how to tackle doing research for an essay, so don't freak out. If you do struggle with writing, come see us and ask questions, and we're more than happy to help you out. And that's kind of key to the semester as a whole. If you find that you're struggling with any of the material, ask a question early. The earlier you ask it, the quicker we can fix it, and the easier it is to fix. That goes for the lectures as well. If you find that I'm talking about something and you're not understanding what I'm talking about, throw your hand up. I'm more than happy to take questions during the lecture. I also tend to talk fairly quickly, particularly English isn't your first language, it can be hard to follow along. So hence the recording. But if you do find me gabbling along and you don't hear me understanding something, don't hear me saying something properly, again, I'm not going to be offended if you throw your hand up and must be repeated. That's fine. So assignment 2 is a research essay. We'll give you a few suggested topics to work on. But if you're particularly passionate about some aspect of data warehousing that you want to do research on, perhaps you're working in the area professionally at the moment and you want to do some research into a particular aspect, feel free to propose that. Just come and see the tutor or myself and we can negotiate a topic with you. So we're more than happy to do that. The exam, of course, is it's a 2-hour closed book exam, so standard kind of exam conditions. A couple of things with the assessment stuff. So this is kind of getting into the nitty-gritty admin side of things. There's 3 criteria that you have to meet to pass the unit. So if you just click to page 4 where it says assessment policy. Most of you will be familiar with this, but if you're not, some students find that they can't wrap their mind around the concept. It's a little bit tricky. I'll just explain it quickly. All units within the Faculty of IT have this policy of the 40% rule. So the 3 criteria to pass the unit are that you need to get at least 40% of the available assignment marks, and that's across the 2 assignments, at least 40% of the available exam marks, and at least 50% overall to pass. So a pass is 50%, but you have to perform to a minimum standard of at least 40% on all of the assignment material, all of the assessment material, including the exam. Now that doesn't mean that, for example, in assignment 1 or 2, if you perform really poorly with one of the assignments, you can't then catch up with the other assignment. You can. It's averaged out across the 2 assignment marks at 40%. But overall, you must get at least 50% and 40% of assignment marks and 40% of the exam marks. Does that make sense to everyone? Okay. So it's not, the 40% rule doesn't mean if you get 40% you pass. You still have to get 50% overall. Just keep that in mind. We do expect you to submit your assignments on time, and you've got the assignment due dates listed here, week 8 and week 11. I might actually push assignment 2 out to week 12, we'll see how it goes. But I'll give you more detail on exactly when and how to submit the assignments, give you the assignment specification. Typically we hand them back in the tutorials, typically you submit during the tutorials, but we might make that the lecture, just because people have got tutorials on different days and it can be perceived as a little bit unfair if you've got a longer tutorial and that kind of thing. So please submit on time. If you do need an extension, please take note of the special consideration policy. There's a link to it from the Moodle website. And for most of you, this is not your first IT unit that you're studying, so you should be familiar with the special consideration guidelines anyway. But there is pretty tight policy on what we can grant extensions for and what we can't grant extensions for. So please, if you think you need an extension, read that special consideration policy, download the form, fill it out, and bring it to me. That's for the assignment work. If you need to perhaps defer the exam and those kinds of things, again, we can take that into account, but go to the special consideration policy website and read the criteria that you have to meet for that. I make decisions on the assignment special considerations. The university, the faculty central makes decisions on the exam special considerations. So I just hear the result of whatever the deliberations are. All right, everything else is pretty straightforward. So there's lots of links to policies and things like that on page 6. We assume you're familiar with those, so if you're not, click through, have a read of them. They're pretty dense though, but just at least have a look through. There's no set text for the unit. We're not requiring you to buy any textbooks, but there is regular weekly readings that we assign via Moodle. So in most cases, there'll be electronic versions of articles that you can download for free. So you won't need to pay for any of that. In some cases, you might have to go to the library or go electronically to the library and download a journal article from there. But we do set readings every week, and we expect you to keep up to speed with those readings. So please don't go behind. You'll find that the lectures and the tutorials will make a whole lot more sense if you keep up with the reading. Are there any questions that you guys have got? No? Monday morning or Sunday with the science or reading? Okay, well let's kick off with the lecture itself. Technology hitches already. microphones connecting to the computer. Let me do it manually for the moment. Okay, so this is what we're going to cover in this week's lecture. I've already talked about the assessment, and I've kind of talked a little bit about the unit introduction. I'll do a bit more about the philosophy of the unit and where we're headed. But the main sort of guts of the lecture are the last two dot points. So some basic definitions, what data warehousing actually is, some different terms that we'll be using throughout the semester so that you understand what I'm talking about as we go. And then a bit of an overview of some research which is actually now getting a little bit old. We must redo the research. But it was a survey of the data warehousing industry in 2000. I still use it because, well, we haven't redone the survey, but the results are actually still applicable to today's industry. And the idea is to give you a bit of an idea of how data warehouses are different to other kinds of information systems, particularly operational information systems like ERP systems, SAP and the like. So a lot of what we're going to be covering over the 12 weeks is highlighting what's different with data warehousing, what's different with business intelligence in general, and what that means for the design and management and deployment of those systems in organisations. These systems are fundamentally different to the more traditional operational information systems, and that's what you guys are here to learn about. Oh, look at that, it's magic. Okay, there's my email address and there's my office as well, so feel free to pop past any time. Can't guarantee that I'll be in there, but if I'm there, the door's always open, so feel free to just pop past and say hi. But my email address is there, and I check email quite regularly. The tutors, I forgot to mention Reza. Some of you have had Reza before. Reza's going to be one of our tutors as well. Andrew, and I've left Felix off the list, but that's okay, he's here to say hi anyway. So the tutors will give you their contact details in the tutorials themselves. Just a reminder that the tutorials are running this week. So some units, the tutors start in week 2, but we start our tutorials in week 1. So don't forget to go along. We make extensive use, as I said earlier, of Moodle. Everything that I hand out will be available through Moodle. So the lecture slides in different formats, the tutorial material, the discussion forums, which I strongly urge you to make use of. For those of you who did 9003, you'll remember how well those discussion forums work. And as I said, it's really about having a critical mass of discussion taking place for it to work. So feel free, post early, post often, that kind of thing. As I said, recording a podcast. So the podcast is mostly of the lecture, but occasionally I'll throw in an extra little perhaps audio interview or something like that, so extra little bits and pieces in that podcast. When it's the lecture material, it's the audio via this and the video I'm recording as well. Similar to Mulo, but the quality is a little bit better. So you can subscribe to that through iTunes, or you can download individual episodes if you like. Just go to this URL here, podcast.infotech/FIT5095. There's a link to it also from Moodle, so you can just click on the link, the button that will subscribe in iTunes automatically for you, or if you don't use iTunes, you can grab the RSS feed for the podcast to listen however you like. So this is what we're trying to do with the unit. We're trying to broadly give you a framework for understanding some of the issues with using data warehousing in industry, in organisations, particularly with a focus on data warehousing, not so much as a particular piece of technology. You can actually use lots of different kinds of technology to achieve essentially the same ends, and we'll look at how some of those different options can be weighed up and chosen from. But looking at data warehousing ultimately as a process of supporting decision making in organisations. So this unit is very much a part of that business intelligence specialisation in the MBIS, and fits in with the other BI units, particularly 5093, which is Business Intelligence Applications. I'm guessing a lot of you will be doing that next semester, or did it last semester. And FIT 5094, which is IT for Management Decision Making. 5094 is kind of the foundational unit for the other BI units, and we operate very much in the same philosophy of understanding the technology in terms of how do we make decision making better in organisations. Now, there's a bit of an industry trend to focus on the technology. Vendors tend to focus on the products that they're selling, that's quite natural, and they market it as such. And the IT industry is just flooded with white papers and vendor marketing material and so on. And sometimes it's quite hard to cut through that marketing material and the focus on the technology as a piece of, as the focus. And remember that what we're really trying to do is improve decision making, which is a human process. So we're going to try in this unit to cut through that marketing material, look at the fundamental issues of using a data warehouse to support decision making in organisations. And I find that thinking of a data warehouse more as a process rather than a thing, a piece of technology, helps with that. It helps you remember what the ultimate aim is. So at its most basic, a data warehouse is a piece of technology infrastructure that supports taking information from source systems in an organisation, points of data collection like ERP systems or inventory management systems or point of sale systems where data is collected in the organisation, transforming it into a format that's appropriate for decision making and moving that to a place where the decision makers can actually make use of it so they make more informed decisions. So data warehouses provide the data infrastructure to do things like decision support and other kinds of business intelligence applications, maybe data mining and those kinds of things as well. So what we're going to try and do, we can't cover every single aspect of data warehousing or every single aspect of trying to support decision making in this unit, but we're going to try and highlight the key issues along the way in terms of designing the infrastructure and the pitfalls that need to be avoided when you're trying to use this kind of technology for decision making. Does that kind of make sense? Okay. Textbooks. Like I said, there's no required text, but you might find some of these texts here useful reading, so you can go out and grab them. There's a gazillion copies of these books flying around, so by all means buy them new if you like, but you're almost guaranteed of finding a second-hand copy somewhere. There's updated versions of all of these. I've got the very first one, the first Kindle book, was published in 1996. It's still worth checking out. It's particularly useful for the dimensional modelling stuff that we're doing in the first couple of weeks of semester. The other books are a bit more recent, and I think there's even there's a 2010 version of the Data Warehouse Lifecycle Toolkit. It really doesn't matter which version you get. We're not going to follow the textbook in terms of lectures, textbook kind of thing, but they're useful for your own background reading, background studying, as we're particularly tackling the first half of the semester. Okay, as I said, we're going to assign readings every week, so we'll provide those readings for you via Moodle. Just keep up to date with those readings. The sort of rule of thumb is that you should be doing roughly 2 hours of reading per week, in addition of your own sort of background study reading, in addition to the readings that we assign. This is a 6-point unit. We assume 12 hours worth of work per week. So there's 2 hours of lecture, 2 hours of tutorial. That leaves 8 hours of assignment work and reading and study and so on per week. So that's roughly what we expect. So to do this unit, what do you need to know? Obviously, FIT 9003 is a prerequisite. Some of you will have been exempted from 9003 because you've done some previous database units. This is not a technically focused unit, as I've sort of mentioned earlier. We're not focusing on data warehousing as a technology artefact. We do play around with a few different tools, but we don't assume any sort of background knowledge of the technology. But the emphasis really is on the design work and the organisational issues associated with deployment of this kind of technology, some of the governance issues, the project management issues, and so on. So this is really a systems analysis and design unit, not a programming unit. We're not going to get you to do lots and lots of SQL. That being said, we do assume that you know a bit of SQL, the basic 9003 stuff that we cover, so the difference between the insert statement and the select statement would be a useful thing for you to have. But if you've got that, you should be okay. The most SQL that we're going to do is actually next week in the tutorials. I'm going to get you to do some SQL to extract some reports from a database with one design versus the database design using the technique that we're going to teach you in weeks 3 to 4, just to get you a feel for why we do that kind of design stuff. So, yeah, a tiny bit of SQL is handy, but don't worry if you haven't got much SQL expertise. You should understand what a database management system is. So if I use the term DBMS, you should know what that means. You should understand normalisation. Everyone remember normalisation? First normal form. Anyone remember? Maggie knows, I'm sure. it's nightmares still. No repeating groups. Second normal form? No. Now I've got to remember. dependencies, no partial dependencies, and third normal form, no transitive or non-key dependencies. Higher normal forms are there, but so long as you understand the vibe, the gist, the thrust, the constitution, the marbo of it, you'll be okay. One of the things we're going to teach you is, after doing all that stuff in 9003, you must normalise. We're going to teach you not to normalise in this unit. We'll explain why. You should also know how to do a bit of your own research. You should be familiar with the library's electronic journal resources. If you're not, check them out. They're a fantastic resource. I'm an academic. I do research as part of my job. And you'd think I'd be at the library all the time doing research. I hardly ever actually set foot inside the library itself. I nearly always get my material electronically. The electronic resources are just absolutely fantastic. You can get just about any journal article electronically through the library's website. So you guys should be familiar with that, how to do that, because you'll find, particularly for assignment 2 with your research paper, you'll need to be reading lots of journal articles and so on. Essentially, if you know how to read and how to think, if you're a student, if you're a postgraduate student, you should be fine for this unit. If you're struggling at all, like I said, ask questions early, ask questions often. We've talked about the assessment. No other questions about the assessment? No. Here's the rough breakdown of what we're going to cover this semester. So the first half of the semester really is on the modelling and design work. So we're going to look at this idea of data warehousing as a process rather than a technology artefact. We'll look at that next week. And then in weeks 3 and 4, we're going to teach you that alternative to ER design, multi-dimensional modelling. So we'll spend 2 weeks on that. The first week, just going over the real basic stuff. Going to break you out of the habit of doing normalisation after spending so much time trying to teach you to do it in the first place. In week 2, we'll do some more advanced stuff, particularly looking at perhaps some of the logical and physical aspects of dimensional modelling. Now, does everyone understand the difference between conceptual, logical and physical? Anyone who doesn't? Because I can talk about it just quickly. No? Okay. So first, week 3 is sort of conceptual modelling. Week 4 is getting into some of the physical design decisions you have to make. Week 5, we're going to look at a topic which actually used to be its own unit within the master's degree, customer relationship management. That's no longer offered as a unit. It's not as sexy a term as in the industry as it used to be about 10 years ago, but it's still something which data warehouses are often used for. It's an application of data warehousing data that's kind of unique compared to other more common uses to data warehousing. So we're going to cover it, and we're going to look at how you might do some alterations to the design work that we covered in week 3 and 4, particularly for customer data and working with customer data and managing customer relationships. From week 6 onwards, we start looking at the organisational issues. So we cover architectural issues in week 6, which is still a technical topic, but it's getting into the area of, well, how does the organisation interact with the data in the data warehouse? How do we structure the data warehouse physically to best cope with that? Then we move into systems analysis and design, so some SDLC methodology specifically for data warehousing type projects. We'll look at some case studies in week 8, highlighting particular organisational issues, particularly the relationship between managers and data warehouses and the information contained in data warehouses, and what impact it has on the information culture in an organisation. Just sort of flagging what we're going to talk about in week 8, one of the big impacts that a data warehouse has on an organisation is that all of a sudden a lot more data becomes available to a lot more people. And that can become a bit of a threat to some managers in organisations who sort of perceive their organisational power, their political power, based on information that they control. If all of a sudden we're breaking down these information barriers, that can be quite a threat to an organisation. So a lot of data warehousing projects have actually failed because they meet resistance in the organisation from managers who want to control the information themselves, rather than this kind of utopian view of information for all, which is kind of underpins the data warehousing mindset. We'll touch on data quality issues in week 9 after the break. You guys will be exhausted by week 8, so week 9 you'll be ready and raring to go again. We'll look at some technology decisions, not so much in terms of choosing one tool over another, but how you manage the technology procurement process for data warehouses, how you interact with vendors, because the vendors are a little bit different to other kinds of vendors in the business intelligence and data warehousing space. In week 11, we'll look at issues of governance. So, like I said, from week 6 onwards, it becomes much more organisational issues to do with data warehousing, whereas the first 6 weeks are designing data warehouses, the modelling, the conceptual, logical and physical modelling, and so on. And then in week 12, we'll have a review and a conclusion. So that's the semester. Any questions before we push on? Okay, when we get to 11 o'clock, and if I don't stop, remind me, we'll take a break halfway through. I'll faint if I go to 11:15 without taking a break, and you guys will just go to sleep. So at 11 o'clock, we'll take a break, 5-10 minutes, and come back and finish. So just keep an eye on your watches. All right, one of the misconceptions a lot of IT folk have about data warehousing is that they take this sort of technocentric view of data warehousing and view it really as a great big database. A data warehouse is a centralised data repository of organisational data. As I hinted at earlier, data gets collected by organisations with lots of different systems. A lot of organisations have ERP systems like SAP, various other flavours of ERP systems out there. Other organisations have sort of individual information systems collecting data like inventory management systems and point of sale systems and those kinds of things. So there's this great flood of data coming into organisations. And when you've got data collected, particularly in disparate systems in an organisation, it can be quite difficult to try to get an overview, a cross-organisational view of how the organisation is performing, the sort of threats, opportunities, weaknesses and strengths kind of thing. When the data is sitting in those separate systems, you have to sort of pull some data out of that system, pull some data out of that system, try to integrate it, and then understand it to be able to make a better decision. So data warehouse is an attempt to solve that problem, to automate the process of taking data out of what we call these source systems or sometimes legacy systems, and import it into a centralised database. So you can see why it's quite tempting to think of a data warehouse as just a big database. Sure, it's got lots and lots of data, but typically it will use the standard database technology. Most data warehouses are developed using standard relational database management systems. There are a few vendors out there who sell database management systems specifically designed for data warehousing and business intelligence. But by far and away, the standard technologies that we use are SQL Server, Oracle, DB2, those kinds of things. However, what we're going to try and convince you of over the 12 weeks is that data warehouses really are fundamentally different to operational databases. They're not just a traditional database, they have different design requirements, different design objectives. And as a result, even though the technology itself might be the same, the way that technology is deployed, the design of the systems needs to be fundamentally different. The way in which we understand the user's requirements and try to satisfy those requirements are quite different to traditional operational information systems. Is everyone comfortable with the idea of a traditional operational information system? I tend to use the term quite a bit. I'm just referring to ERP systems, systems that collect operational data from organisations. Okay, so a data warehouse is essentially a copy of that operational data. It takes a copy of the data from those source systems, integrates it, perhaps reformats it, and makes it available to users who perhaps use other systems, decision support systems and business intelligence applications, to easily source that data and report on it and understand it. However, the central argument, the argument that data warehouses are fundamentally different is actually quite nicely encapsulated with a quote from a book written by Bill Ingmon and Richard Hackathorn. This is kind of one of the earlier books on data warehousing. Data warehousing actually goes back to probably the 1980s in terms of its theory and practice, but became really popular in the 1990s as more and more organisations had larger amounts of data and they were trying to make sense of that data for making decisions. So Bill Ingmon and Richard Hackathorn wrote this book that became a kind of Bible for data warehouse developers in the 1990s. But I haven't seen anything since then that so nicely encapsulates the fundamental differences between an operational database, even large operational databases like an ERP system, and the design requirements for a data warehouse system, a system designed to support decision-making in an organisation. So their definition comes down to 4 key points. So they argue that a data warehouse is a subject-oriented, integrated, time-variant, and non-volatile collection of data to support decision-making. So those 4 things are key. I strongly urge you to remember those 4 things when it comes time to the exam. So subject-oriented, integrated, time-variant, non-volatile. It'll become a bit of a mantra for the unit as we go along. So let me explain what I mean by these things. Even though it's 4 different terms, they actually group into two things, 2 kind of aspects of data warehousing. The first, subject-oriented and integrated, refers to the fact that when you have an operational database management system, it's typically been normalised to at least versional form, a bit higher level than normal forms. And what happens when we normalise? When we go through the normalisation process, what happens to the design of the database system? Get rid of redundancy, but in terms of the physical structure of the database, what happens to it? More tables, exactly. So you end up with the same data, but split across multiple tables. And this is a good thing from an operational perspective because it removes redundancy. It means that data is stored once and only once. And it means that if you need to make changes to that data, you can do it in one place quite easily. With a data warehouse, though, what we're often dealing with are queries or questions from senior managers in an organisation who are trying to make sense of sort of the overall view of the organisation or perhaps a business topic and make a decision about that business topic. So they may want to, for example, understand who are our top 10 customers. So that the data warehouse needs to try and provide the data to nest that. In a fully normalised database, customer data might actually sit in 3, 4, 5 different tables. And in an organisation with multiple information systems, that customer data may sit in 3 or 4 different information systems as well. So a normalised traditional operational database tends to have split data organised or structured according to what's most efficient from a data management perspective. What the users of a data warehouse, though, are trying to grapple with is to understand the data from a business subject perspective. One of the key things with a data warehouse is that, well, one of the key differences, which I should have explained before I got to these quotes, is that the underlying data structure in a data warehouse is much more exposed to the end users than you get with traditional operational information systems. So when you're designing an operational IS, you come up with a database data structure, and then you typically, on top of that, you'll build a user interface, some data entry screens, some reports, and so on. And you can hide the complexity of those split tables, those normalised tables from the end users using the sort of user interface. So you can structure the user interface according to the workflow rather than the data structure. So you get the best of both worlds. You get the benefits of the data management of a normalised data structure, but you can then hide that complexity using the user interface for data entry and data retrieval. With the data warehouse, though, we don't know, we can't predict beforehand what the workflow is going to be. And if you're, for those of you doing 5094, you'll understand soon exactly why that's the case. For everyone here, I'll just give you a very quick overview. And we've got a slide coming up that talks about it in a bit more detail in a second. But with decision-making in organisations, when you've got systems supporting decision-making, it's impossible to, except for the most simple decisions, to actually predict exactly the course that a decision maker is going to take through a particular decision problem. The situation we had before, the very need for a decision support kind of system, IT for decision making in an organisation, is based on the fact that people lack information. There's ambiguity around the decision problem. If people had all of the information that they needed and they understood the decision problem quite well, they wouldn't need IT support to make that decision. So this is why I say, apart from the most simple decision problems, this is not the case. So decision makers don't know exactly what they don't know. They don't know what they need until they start exploring the data, until they start learning about the decision problem. And as they learn about the decision problem, this creates brand new questions. So that question I said before, a typical question of a manager of who are our top 10 customers, you answer that question with a report, fairly straightforward, simple piece of SQL perhaps. That's probably not going to satisfy all the requirements. They're going to look at the report and go, okay, well these are my top 10 customers. Why are they my top 10 customers? What is it about these customers that makes them most profitable? How can I make other customers more profitable? That leads on to a whole set of other questions. So you end up going through this continuous cycle of question and answer, simply by dint of the fact that there is a need for technology support for decision making in the organisation. If people were able to make decisions without the technology, they understand the problem perfectly. So we've got this chicken and egg problem then. We don't know what the users are going to need at the start of the systems development process. They don't know what they need. It's not until they have the system that they start to learn that. So how do we design that first system? Becomes a real problem. Oh, I've deviated quite away from this slide. Now I've got to try and find my way back. Okay, so, I remember now. It was all about exposing the data model to the users. The kind of usage pattern of a business intelligence and decision support system application is about exploring the data in the database, in the data warehouse, or the data that's available. So the user interface isn't this nice kind of workflow of data entry screens and data retrieval screens and standardised reports. The typical business intelligence user interface is perhaps something similar to Excel or a pivot table kind of structure in Excel. I'm not sure how many of you have come across pivot tables before. But it's an interactive environment. You pull up some data, it might be displayed as a graph or a chart, and you can usually interact with that data. So you might click on a slice in a pie chart, and that might take you to some more detailed information that made up the numbers for that particular component of the chart. And you start moving around through the database. It becomes a much more exploratory process as the users learn about the decision problem, as they look for data to answer the questions that arise from the previous answers to the questions that they had before. Does that kind of make sense? So BI, decision support, is very exploratory, it's very unpredictable, it's evolutionary, whereas operational information systems is much easier to come up with a standard, okay, if you're going to use a system, you'll do this step, and this step, and this step. So the complexity of the data structure becomes much more apparent with the data warehouse. To aid that exploration of the data, and remember we're talking about mid to senior level managers often who are the users of these systems. They're not IT professionals. They're probably comfortable with technology, but they don't, in most cases, can't code SQL and things like that. So we need to make sure that the data structure is simple to navigate because it is a fundamental part of the user interface. The data structure becomes the user interface. So that creates a design problem for the data modelers designing the data warehouse. So instead of structuring the data in a normalised kind of structure, third normal form or higher, with split tables and things like that, we want to group the data according to the kinds of business subjects that our users are going to be asking about. So we want to group the customer data together, we want to group the sales data together, we want to group the inventory data together. So that normalisation process defeats that purpose. So this first element of the eModern hackathon definition is that the data is structured in a subject-oriented way, not a data-oriented way. So looking at customers and claims and shipments and products and things like that, rather than splitting across multiple tables. This is very different to the, as I said, the process, the workflow process orientation of more traditional transaction processing systems. There's a term some of you may have come across before, others perhaps not, OLTP. That's just an acronym to refer to these operational information systems that are collecting data. Essentially, they're systems designed to process transactions rather than support decision making. So you'll see me use that term a little bit. You'll also see me use the term OLAP, O-L-A-P, to refer to business intelligence and decision support systems. OLAP stands for Online Analytical Processing. So transaction processing versus analytical processing. There's some BI practitioners, business intelligence practitioners, who actually no longer use the term business intelligence, but actually use the term business analytics to represent the idea that really what our users are doing are analysing data, trying to understand the data, to understand the business better, to make better decisions. Anyway, so that's the distinction I'm making. So OLTP systems, typically normalised to third normal form, process-oriented, whereas OLAP systems, data warehouse systems, are much more focused on subject-structured data. That typically means that we need to integrate the data from multiple tables. So instead of having disintegrated data in a normalised database, the data warehouse will integrate that data together. Now there's two aspects to that. One is you might be integrating data from multiple normalised tables in the source system. So taking data from one source system, it's normalised data, so you have to try and integrate it to come up with this subject-oriented view. But you've also probably got multiple source systems in the organisation. A lot of data warehouses will have a large number of source systems feeding into them. It's not unusual to see 15, 20, 30, 40 systems all feeding into a single data warehouse or data warehouse structure. So not only are you integrating data from one database, denormalizing the data, but you're also integrating data from multiple sources as well. And when you've got multiple source systems, you've almost inevitably got different design approaches, different design patterns, different ways of structuring the data, different standards of naming objects and things like that. For example, one source system might have customer information with an address field, and the state takes a 3-letter code, NSW, TAS, that kind of thing. Another system may have the full name of the state, so Victoria, Tasmania, and so on. So when you're bringing that data together, you need to be able to identify the fact that the 3-letter string TAS is exactly the same real-world concept as the, how many letters are in Tasmania? Whatever length string Tasmania is in another system, you need to be able to integrate those often disparate data structures and data formats together in the data warehouse. So with a data warehouse, it's a subject-oriented view. We're trying to create with a data structure, an integrated view of the data from across multiple source systems, multiple tables, to try and achieve that subject-oriented view. Now to do that, we have a process called an extract, transform, and load process. This is something we'll talk about a little bit later in a couple of weeks' time. In fact, next week we'll talk about it in more detail. But the data warehouse sits at the end of a process, an automated process that on a regular basis takes data from the source systems, extracts that data, transforms that data to create that subject-oriented and integrated view, and then loads it into the data warehouse to make it available to the data warehouse users. Does that make sense? So you'll see that the acronym ETL used quite a bit in industry literature, and that's what it means. So that's the first two, subject-oriented and integrated, so two related concepts. The other two related concepts refer to the nature of the data that we're keeping in a data warehouse. And again, this is a direct contrast to the more traditional OLTP transaction processing systems. With data warehouses, because we're supporting decision making, trying to support better understanding of a business to help decision makers make better decisions, very often what we're trying to do is look back over time at data. So what were sales last month versus the month before versus the month before, or how did sales in January this year compare to sales in January last year? Who are our profitable customers from last year versus this year? So time tends to be a significant component of the kind of data that we're using to answer the kinds of questions that our users ask for. So with an OLTP system, a normalised database, what would typically happen if a customer, for example, changed their address and they let us know? You'd probably overwrite that customer record in the customer database, which is quite a reasonable thing to do. If you want to send out a letter of some marketing material to that customer, you want their current address. But for decision-making purposes, it's sometimes quite useful to see where a customer was demographically a year ago. So you might do, say, postcode analysis of the different customers you've got. And from that, it extracts some demographic information about perhaps their socioeconomic status and things like that. And you may want to see how that changes over time. So with the data warehouse, we want to be able to identify the fact that the customer used to live in one area and now lives in another area. We don't want to overwrite that data. And that's typically quite true of most of the data in our data warehouses. We want to look at sales data as it changes over time. So this idea of data being time variant is quite important for data warehousing, but it's quite the opposite view that we have for transaction processing. So with business transactions, we're interested in sort of that snapshot of time. What was correct at the time this transaction occurred? So there might be a date and timestamp on a sale, for example. But with a data warehouse, we're not looking at a single snapshot, we're looking at a series of snapshots over time, so we can see how the data changes over time. Does that make sense? Okay. So data in the data warehouse typically has an historical aspect to it and builds up over time to create a series of these snapshots. So every time we run the ETL process, extract data from the source systems, we get another snapshot, and that builds up like a video over time. We can see how things change. And that allows us to do trend analyses and things like that. The flip side of that, of course, is that we therefore don't want to ever delete data in a data warehouse, or rarely do we want to delete or overwrite data in the data warehouse. Instead, we want to add to that snapshot over time. So with an OLTP system, overwriting data is actually quite common. You might edit or delete records. With a data warehouse, we very rarely edit or delete records. We simply add to the data warehouse, create a new record. Which means that over time, you end up with multiple records in the database referring to the same real-world object. So the same customer might have multiple records in the data warehouse as they change their address or make multiple sales, whereas in the customer database, the transaction processing database, you'll only have one record for that customer. Okay, so non-volatile. We don't want to overwrite. Inserts and deletes and changes are quite rare in the data warehouse. Instead, we tend to refer to, it's become a bit of a, not as common a term now, but we used to refer to the idea of upserting data. So instead of inserting data, we upload data from the source system into the data warehouse to add yet another snapshot to the overall picture of the organisation. So those four things, subject-oriented and integrated, and time-variant and non-volatile, they kind of go together. They epitomise the fundamental difference in terms of design requirements, in terms of usage patterns of a data warehouse versus an operational database system. So this is kind of the core of the argument of why a data warehouse is not just a big database. There's different design requirements for a data warehouse compared to operational information systems. And a lot of IT developers, a lot of data warehouse developers, a lot of database developers who, for the first time, go into a data warehousing project, get caught out with a significant amount of surprise when they try to design these data warehouses. Data warehousing has a really high failure rate, particularly in the 1990s. There were lots of spectacular data warehouse failures. Reported in the news and literature and things like that. Seems every bank in Australia has had 5 or 6 goes at building a data warehouse. They kind of work now, but the first few goes, millions and millions of dollars were lost because IT developers didn't understand the fundamental difference between building an operational system, the operational database, versus building the data infrastructure for decision support in an organisation. So we're going to spend 12 weeks working out what that difference is, making you aware of what they are, so that you can hit the ground running. You can design successful data warehouse systems from day one, hopefully. Yeah, exactly. This is a good point to take a break anyway. So we'll take a 5-minute break. Go out, grab a water, grab a coffee, something like that. Come back and we'll come back at 11:05 and we'll kick off with the rest of the material.
First lecture.
Yeah. More coffee?
No.
Hey, how are you?
Good, how are you?
Good, thanks.
How was your break?
Yeah, it was good. Yeah,
Quick
sure.
question. I'm wondering when I can switch my tutorials and join yours.
Possibly. Is the one that you want to transfer to full, is it?
Sorry?
There's no room in the...
Yeah, your one.
Okay.
When on our
Yeah.
seats there.
Is it a time thing, or is it just... Okay. Yeah, look, come along, see how full the tute is, because, not everyone necessarily turns up. So if there's room, I'm more than happy for you to come along. Excuse me.
Yeah, sure.
See how it goes for the first couple of weeks, and if there's room, then we'll do the formal transfer. Otherwise, see how it goes. Cool.
Yeah, I was just wondering, do you know exactly when the tutorials are? Do you know if the one that today at 6 is still available?
Kind of. No, it's not available,
Yeah.
but it's still there in the background.
Okay.
So if we get the numbers, we'll reopen it.
Oh, okay.
At the moment, we don't have enough numbers to
Oh, all right.
and there was a fairly high demand for the one in the morning tomorrow.
Yeah, that I just changed into.
Yeah,
Exactly.
So that one's, if we get an influx of, say, another 10 or so people, then the evening one will open up.
Oh, okay. So it's not, it doesn't exist, but it
It doesn't
exists.
exist, but it exists
Yeah.
in theory. So.
All right, perfect. Yeah, because I wanted to change to that one
Yep.
specifically, but since it was full anyways, just take a look at that. All right, cool. No worries. Thanks.
That's the Tuesday morning. No, Andrew's... Actually, no, Andrew's doing 9 or 3 months. So, yeah, no, the one that's got an I'm hoping you'll get have you ever met Sydney Madrid? She hasn't tutored before, but she's about to start a PhD and she's when I said Andrew was one of the top students, Cindy's the top student. So she knows the stuff really well. And she's also working on data implementation for large insurance companies, and she really knows this stuff. But because she's doing that, she may not so she's still approaching that teaching. So it'll be me this week, but hopefully from next week on. Yeah, but she needs to do it very fast. So, but all the tutoring activities will be responsible for exactly those things. It does. This is very hands-on. Very much information. Depending on the unit, we play around a bit here. In terms of technology focus, this is the most technical. It's more sort of the second most. And the yeah, well, if that's the case, then that's okay. But in terms of covering organisations, basically BI systems, so enterprises is really but if you're interested in information, Okay, we might get back into it. I know there's. I sort of use Vanjie as my rule of thumb when the class is back or not. She's not, but we're now at 11:07, so we'll kick on to make sure we get through the material. So what we've been talking about is the fundamental. Thanks, guys. So what we've been talking about is the fundamental difference from a design perspective of the requirements for a data warehouse versus a more traditional transaction processing system. So with OLTP systems, we can often use a more traditional waterfall type approach to the SDLC. You know, grab the information requirements, design to those requirements, implement, test, deploy, and then the users actually use the system. With a data warehouse, though, it's quite different. We don't know what users want until they start actually interacting with the system. So we've got, as I said, this chicken and egg problem of we don't know what the design requirements are until they use the system, but we don't know what the system's going to look like until we've got the design requirements. So that's quite a challenge there too. But from a use perspective, data warehouses are fundamentally different to OLTP systems as well because they're subject-oriented and integrated rather than data-oriented and disintegrated. And they're time variant and non-volatile, whereas OLTP systems are sort of snapshots, single snapshots in time. So they're not, the data gets overwritten, we don't keep old data around very often. And we see that in the modelling techniques that we use for OLTP systems, particularly ER modelling. Entity relationship modelling explicitly excludes the idea of time as a sort of modelling concept. For those of you who've done 9003, you remember we had a bit of a lecture on how you incorporate temporal aspects into your models, given that ER models explicitly say time shouldn't be a part of the model. With data warehouses, time is nearly always a part of their model, which poses a challenge for using ER modelling to design the data structures for a data warehouse, which is why we'll look at multi-dimensional models in weeks 3 and 4. So just to summarise the key differences, the key usage differences between OLTP and OLAP or data warehousing type systems. OLTP systems are very much process oriented. They're about workflows, capturing business events. So a sale, a purchase, a payment. So it's an atomic unit of sort of business data. Very often these systems are used by frontline business people, checkout operators at supermarkets, payroll clerks, warehouse managers or warehouse employees and so on, dealing with inventory management systems. So the data has to be available very quickly. It's usually very small, atomic amounts of data that are being accessed with each sort of transaction in the transaction processing system. So you go to a supermarket with your groceries in a trolley, the checkout operator scans a product and it goes beep and appears on the screen. So a very tiny little bit of information. The barcode goes from the barcode scanner to a central database. A little bit of data comes back about the product, basically the price and the name of the product and so on. And that continues until you've finished checking out your groceries and a total is calculated. So we're talking, in terms of volume of data, that's actually quite a small amount of data for each transaction. You might be talking, I don't know, a couple of kilobytes perhaps, maybe at most a megabyte per transaction there. With a data warehouse system, of course, that's quite different, and I'll explain that in a second. But you want the data to be small because you need a high level of interactivity with those OLTP systems. You don't want to be standing around while the cash register downloads a terabyte worth of data about products to be able to check out your groceries at the supermarket. It needs to be quick and interactive. You go to the bank, you don't want the teller sitting around waiting for a minute or two for the system to update. So small amounts of data per transaction, but these systems often see a very high volume of transactions per day. So an individual cash register at a supermarket might go through hundreds or maybe 1,000 or so transactions per day. A bank teller, or say an ATM machine, automated teller machine, may go through thousands of transactions per day. Data warehouse, business intelligence application, you might go through maybe 1 or 2 a day, maybe even just 1 or 2 a week. So low volumes of transactions. But in terms of the data volume, that 1 or 2 queries per week may be looking at what were all of our sales for last year, and that may be terabytes worth of data. So an OLTP system, small amounts of data but high traffic. Data warehouse system, low frequency, low traffic, but large amounts of data that are being delivered. So again, a fundamental design difference. So OLTP systems tend to be much more interactive although again the data warehouse is interactive, so we need some design tricks to be able to handle those volumes of data and still remain interactive. But characterised particularly by data entry, data updates and data deletions. So data modification, creating data and modifying data in transaction processing systems. OLAP systems, data warehouse systems, we're not so much concerned with data entry because that's handled by the source system already. And because we want that non-volatile, time-varying view of the data, we very often don't want to change the data or delete the data either. So the most common SQL transaction for a data warehouse system is not insert, update or delete, it's select. That's the most frequent transaction at the SQL level that one runs against a data warehouse. Whereas for OLTP systems, it's much more balanced. There's much more insert statements. There's a lot more update statements occurring. And OLTP systems, of course, are very often focused on one particular area of the business, even to the point of one particular kind of transaction in the business, specialising in just that transaction. Whereas a data warehouse system tries to provide a cross-organisational view, getting a view across the organisation so that strategic decision makers can make organisation-wide decisions. So OLAP systems, BI systems, data warehouse systems, generally used by decision makers rather than sort of people at the bottom levels of the organisational hierarchy. So business analysts, middle level managers, senior managers, consultants and so on, to make often tactical or strategic decisions in organisations. This is as opposed to, say, operational decision making, which tends to be much more routine, much more structured in the kinds of decisions that are required. You can often support those operational decisions with what we call standard or standardised reports. These are reports that you might run once a month or once a week, and they're the same structure every time. So you hit a button and out pops the weekly sales report, for example. The kinds of decisions that data warehouses really are geared to support, though, are these strategic, what we call semi-structured decisions. And so the usage is much more characterised by analysis, so doing analytics rather than, or what we call ad hoc reporting rather than standardised reporting. We don't know what report a manager is going to run, what data they're going to extract to answer their particular question at that particular point in time, because they don't know beforehand either. So the tools that an OLAP or BI system will use support that ad hoc style of reporting, the ability to easily pull in one data from one part of the data warehouse, some more data from another part of the data warehouse to see how they interact with each other. You'll get a much better idea of this as we go through the dimensional modelling side of things in weeks 3 and 4. But it's very, very much cross-organisational and integrating data from a number of different sources in an unpredictable kind of way. So very, very different to OLTP systems. And as I said earlier, characterised much more by data reading, those select SQL statements, rather than data entry, data modification. Does that all make sense? So have I successfully created that initial argument that data warehouses are not just a big database? They're fundamentally different to other kinds of transaction processing systems. Okay, to give you a bit of an overview of the kind of architecture that we're kind of talking about here, a data warehouse provides the data infrastructure to do decision support in organisations, whether it's business intelligence or other kinds of analytics. But the data warehouse sits in the middle of an overall data warehousing process. This is why I kind of prefer to talk about data warehousing as a process rather than a technical artefact. Because we're moving information from source systems, bringing it together through the ETL process, extracting, transforming, and loading that data into the data warehouse, and then pushing that data out or making it available for pulling from people who are actually interacting with decision support systems and other kinds of analytical systems. So when we talk about data warehouse users, we're typically not talking about people directly interacting with the data warehouse. Typically, our users interact with the data warehouse via other systems, business intelligence systems. But those business intelligence systems can all plug into the same data infrastructure. Okay, so do you get that kind of idea of data warehousing as a process rather than just a single thing? So what we're talking about in our unit kind of starts about here and it kind of ends about here, but it talks about these kinds of issues about designing these systems too a little bit. So I tend to call these the delivery systems versus the data warehouse or sourcing systems. source systems, data warehouse, delivery system. So the system that end users actually interact with. Now, there's a bit of an artificial distinction there, in that it's tempting to look at the data and the data warehouse, the data layer, and say, okay, we're going to build a data warehouse, and then we'll think about the delivery system later. But as we'll find out, the design requirements for the data warehouse are often driven by the same design requirements as the delivery system. And as I said earlier, we don't know what those requirements are until people start using the system, start asking questions and start getting answers. So designing this independently of this often leads to a situation where the requirements change here, but they're not supported by the data infrastructure. So it does have to go kind of hand in hand. You get a slightly different view from David Arnott in 5094. He argues that the data warehouse layer shouldn't be hampered by the delivery system layer. Essentially, his argument is you shouldn't wait to do the delivery system while you're trying to get the data warehouse right. You can separate the two, start working on the delivery system, because this is really the point here. This is where the requirements start to come from, because that's the tool that the end users work with. So David in 5094 argues that there should be a bit more of a separation here, and you shouldn't wait to do this before you do this. My argument is that you really need to do them together, I think. Who's right? Well, I don't know. We've seen projects work with both kind of ways, and we've seen projects not work. And David's got a spectacular case where it didn't work in another. At some stage, for those of you who are in Steve Remington's tube, I'll get you to ask him about a particular data warehousing failure case that he worked on. Some interesting insights there. Okay. So, why do we do data warehousing then? Well, the core fundamental aim of doing a data warehouse is to improve organisational decision making. If you're building a data warehouse for any reason other than to do that, get out. The project's going to be a disaster. You don't want that project on your CV. The data warehouse must be driven by a need to improve organisational decision making. If it's not doing that, then you're working to the wrong design requirements, which means you probably don't have a very good, or the team doesn't have a very good understanding of what the requirements actually are. But it's also quite tempting to build a large-scale data warehouse and just pour as much data into it as you can, because it's kind of fun to build big things. People talk about, in their CVs, I built a 5 terabyte data warehouse. That's great, but yeah. Did it actually help improve decision-making in the organisation? We don't know. So data warehouses are there to try to provide the data infrastructure to improve decision-making in organisations. And there's a few aspects to doing that. And the vendors have a few different arguments when they're making their sales pitch to organisations to try to convince organisations, yeah, well, we probably need a data warehouse and we're going to buy your product and your consulting services to help us do it. One of the first arguments is that when you're running queries against a database, there's a certain processing load associated with it. With most transaction processing systems, a query might take, I don't know, 0.01 of a second to run. For those of you who did 9003 with me, remember when we did the SQL assignment and I asked you to take note of how long the query took to run? What was the most common runtime that you had for those queries? Usually I get 0 when I run it because the data has been cached and it's so quick that it doesn't even register as a 0.01, it's just 0 seconds. So DBMSs are quite good at doing small transactions quite quickly. But remember I talked about how a data warehouse, often the data that we're accessing can span multiple terabytes perhaps. So someone might run a report to say, well, what were the sales for last year, broken down by month? And to do that, you've got to go trawl through all of the sales data for, say, 2010, and there might be multiple terabytes of that. The more data you've got, the longer the queries take. And it's not unusual for some queries on these kinds of reports to take hours, maybe even a day or so, 10, 15 minutes. Now, if you're trying to create an interactive environment where the users are exploring the information space contained in the data warehouse, trying to answer questions, and that's firing off new questions, and they're trying to then answer those subsequent questions, it's this kind of rapid-fire train of thought. We're trying to support a train of thought as the users explore the data. You've got to sit around for 15 minutes waiting for a report to run. You go away, perhaps check your email, grab a coffee, come back, and in 15 minutes time you go, why did I run this report? I can't remember the reason. So you want the data warehouse to be as quick and snappy as possible, and we can do a number of different structural tricks in the way we design the data structure in a data warehouse, or how we set up the DBMS to make those kinds of queries run much, much faster. And there are different kinds of tweaks that we do for that kind of data versus the OLTP style systems that have high volumes of transactions but small data sizes. So the way you configure a DBMS for an OLTP system excuse me, is very different to how you configure a DBMS for a data warehouse system because of that fundamental different usage pattern. So one of the selling points of building a data warehouse is that you can then run your reports from head office against the data warehouse rather than against a system that's designed for a transaction processing job. And it means that the users of the transaction processing system don't all of a sudden see the system become really, really sluggish as it tries to handle a massive query as some manager in his office is quick and grab a coffee and the report's running in the background. You don't want to be a customer at a bank teller or at an ATM waiting for 5 minutes because someone, the CEO in Sydney's gone, I want to run a report. So the data warehouse allows you to hit a different system. That data warehouse then spends its processing power dedicated just to handling queries and reports, while the transaction processing system is protected to handle the actual transaction processing tasks it was designed to do. It's called query drain. So this idea that you run a query against a database and the system then slows down as it tries to crunch through the query. You want to protect your transaction processing systems from query drain. Yes, query drain, D-R-A-I-N. So the idea that you're draining the power from the transaction processing system. It's this idea of the system slowing down. So you want to protect your transaction processing systems from that. They need to be snappy, fast, responsive. Data warehousing also allows you to redesign the data structure to present that subject-oriented and integrated view of the data. Now, we don't actually have to implement a data warehouse structure to present that integrated view. You notice that there's a number of different layers of interaction between systems. It's actually quite possible to do essentially virtual mapping of physical data structures to a logical data structure that the end users actually see. So we could actually put in a middleware layer here that translates perhaps a normalised data structure and presents a subject-oriented and integrated view of data to the end users here, just through middleware, through metadata and creating customised views and things like that. However, if we're doing that, that slows down the interaction at this level. There has to be a translation. Every time someone tries to access customer data, that same translation, that same mapping, has to occur to the physical database. So by implementing the subject-oriented perspective at the physical data structure layer in the data warehouse, it means that you can customise the data structure to perform well for select queries, large select queries, whereas your transaction processing systems, you can design them in a normalised way, in a way that makes it efficient to handle those individual small transactions. Because those are two different design requirements, by separating the systems out, you can have a data model geared towards select queries at the data warehouse and a data model geared towards transaction processing at the source system. The source system at the far end. Does that make sense? All right. So, customised design to make efficient data retrieval. Also, we often have a problem with data quality in our source systems. Anyone who's ever worked with a database in real life, for a real life organisation, is aware of how poor the data quality is in most corporate databases. Vanji was nodding her head vigorously in a second. I might get you to talk about your experience later. But I did one project. It wasn't a data warehousing project. It was a data quality audit for a large financial management company. It's no longer around. It's been acquired by other financial management companies. But it was a household name at the time. And the way financial management services companies work is that they invest their money in stocks and shares and so on, paying out and things like that. So they need to keep fairly good track of what stocks they own, the portfolios that they have, the performance of those stocks and shares over time. So I was doing an audit of basically their share portfolio database. And the data quality in that system was just atrocious. It started off with the data model. The data model itself was designed by some cowboy who didn't know the basics of normalisation for a start. And that contributed to the data quality problem. But there were data entry issues and things like that. So I reckon maybe 3/4 of the records were perhaps accurate in that database. And this is the database that the organisation used to keep track of what investments it had. We're talking billions of dollars of shares. So, fundamental. If they were going to get any data right, you'd give that data. And it was just atrocious. I'm also doing some work with a non-profit organisation. They've got lack of resources. They don't know how to use their IT very well and things like that. It's a membership-based organisation, so keeping track of their members is quite important. Who's a current member, who's a former member, when their dues are due and things like that. So it's a fairly small database. They've got maybe 800 members or so. You'd think they'd be able to keep on top of that. They don't know who their members are, basically. And we're talking maybe 12 months of that database in operation. It's already poor quality. So data quality is a real problem for every organisation. I've never seen a database where the data is 100% perfect. It's just a fundamental problem. There's all sorts of reasons for that problem, but one way of tackling it is to actually build a data warehouse. By building a data warehouse, you're looking at the organisation's data resources, what data is available to feed into the data warehouse. And because you've got an ETL process, sourcing data, extracting it from the source systems and loading it into the warehouse, you've got an opportunity to fix up some of those data quality problems. So you can make amendments to the data because you're transforming the data anyway, and as you're loading it into the data warehouse, you can end up with a cleaner data stream. Some of the data quality problems also come about because of that disintegrated nature of OLTP systems. The fact that data sits in one system over here and sits in another system over here. So simply by integrating the data and lining the data up, you can realise that, or work out that, a customer with one name over here, John Smith in this database, is the same John Smith in this database. So two records are actually the one person. So that can improve the quality of the data in the organisation. And in some cases, the data warehousing project not only sources the data and cleanses it as it goes into the data warehouse, but engages in my favourite sort of IT plumbing term, backflushing the data back to the source system. So feeding back the improved quality data back to the source system so that their users have got better quality data as well. So one advantage of doing a data warehousing project is that the source system's data can be improved. We can deal with some of the data quality problems, and we can get that sort of cleaner, better quality data with an integrated view made available to organisational decision makers. Ultimately, well, one of the strongest arguments that vendors have is that it makes it cheaper to source data for decision support. If every time you build a small decision support application or a BI application, and sometimes you throw together a spreadsheet to do a bit of analysis on a particular decision problem, you answer the question and you throw it away. So a lot of business intelligence systems or decision support systems are what we call ephemeral systems. They don't stick around. They're not long-lived transaction processing systems. They answer a question and you throw it away. If you had to solve the data quality and data sourcing problems of getting data from source systems every time you build one of those small-scale systems, it's going to be really quite expensive. I mean, in some cases, you may decide not to build the system at all. So by having a data warehouse, you solve the data quality and data integration problems once. You make that data available then for small-scale systems, large-scale systems, whatever. It becomes an organisational resource that can be used and reused, and therefore becomes a cheaper prospect. So the argument is it reduces the cost of providing data for DSS. The counter-argument is that very often data warehouses cost millions and millions of dollars to build anyway. So it's hard to estimate the return on investment for a data warehouse. So some other arguments are that by building a data warehouse, you're automatically taking this cross-organisational view of the data. So instead of focusing on a particular business transaction when you're designing an OLTP system, a data warehouse is inherently a wider perspective of the organisation. So you're looking at the data that's available, you're looking at the information that's gathered through different business processes. It all of a sudden becomes an opportunity to perhaps think strategically about those business processes, about the structure of the organisation. So a lot of organisations will perhaps go through a strategic review or engage in what's known as business process re-engineering, sort of a term from the 1990s that's not as popular now, but basically looks at the idea of how does the organisation operate, how can we improve things and make things better and change that structure. And a data warehouse might inform that process, or it might be the outcome of a re-engineered organisation. So that can sometimes go hand in hand. Data warehousing also allows you to do things that you wouldn't
have been able to do without that integrated cross-organisational perspective of the data. So things like balance scorecard, other kinds of business performance measurement or business performance management or corporate performance management. I've seen all sorts of different acronyms for the same thing. Those kinds of activities require data from lots of different parts of the organisation to analyse how the organisation is performing overall. It's the kind of information used by senior managers to get that cross-department, cross-organisational view. CRM, customer relationship management, again, customers interact with lots of different parts of the organisation. If you don't have that cross-organisational view, you end up with a disintegrated view of the customer, whereas CRM relies on this idea of a holistic view of the customer, recognising that two records in two different databases are in fact the same person, or sometimes the opposite actually. Sometimes it's quite useful to know that two different people in two different databases with the same name are in fact two different people. It's important to know, and something that's difficult to do unless you get that cross-organisational perspective. The classic, my favourite reason for building a data warehouse, and you'd be amazed at how often this is the sole reason an organisation will engage in a data warehouse. About 10 years ago, an industry analyst report came out. It's not Gartner, but it's a Gartner-style organisation. They produce reports, they do research. And they wanted to get a feel for the data warehousing industry and see how successful data warehousing is in organisations. So they wanted to know what the return on investment was for data warehousing projects. So what they did was they surveyed a bunch of organisations who'd done a data warehousing project and said, well, how much did it cost and how much do you think you've got back in terms of benefits? And they added it all up and did an average, and they came out with a figure of, well, over 3 years, the average organisation gets back 401% return on investment. That's a pretty good figure. I'd invest my money in a data warehousing project. Forget the bank, I'm going to get 401% over 3 years. That's fantastic. What the analysts didn't tell you, or tell the readers in their report, was that there was a really wide discrepancy between the responses they got. So the standard deviation in terms of return on investment was massive. No one actually got 401%. A few people got thousands of percent. A few organisations got negative thousands of percent. There's a few others in there. So the chances of actually getting a return on investment is, it's not guaranteed. The other thing they didn't specify was how they actually sourced the participants in the survey. What they'd actually done was the research was sponsored by a few vendors, and the research firm said, well, we need to get some people to fill out this survey. Can you give us some names? So if you're a vendor trying to sell data warehousing and you're doing this research, or you're getting someone to do this research and you're asked for some reference sites, do you give them the failure cases or do you give them the success cases? The success cases, of course. So the data is naturally skewed to those successful data warehousing projects and ignores the failed data warehousing projects. But this figure gets around. So the report got published. It became this kind of folklore within the IT industry. Build a data warehouse, you're going to get these kinds of returns. CIOs read that. CEOs read it in magazines and they go, well, I need a data warehouse, without really thinking about where did this figure come from. So, as I said, I'm absolutely gobsmacked that I've ever seen it once, let alone multiple times, that this figure is the sole reason an organisation will launch a data warehousing project. But it happened. Anyway, perhaps the most compelling case for building a data warehouse in an organisation, the most compelling message that vendors are able to put out, is that it allows organisations to remain competitive. Of all of the points that we've looked at up until now, this is actually probably the most realistic reason for building a data warehouse. It's kind of that classic problem of IT in general. What's the competitive advantage of deploying an IT system? IT can allow organisations to do innovative, creative things in their organisation, do new things and so on. But typically, the reason why an organisation will have computers in their organisation is because their competitors have got computers, and if they didn't have computers, they'd be left behind. So it's about keeping up with the competitors. And if your competitor has got a data warehouse and is better able to understand their business, then they can identify changes in the market, changes in opportunities and things like that quicker than you can. So one good reason for building a data warehouse and doing business intelligence is to keep up with competitors. All of these other dot points that we've looked at, there's actually counter reasons as well. So this idea of query drain that I was talking about before, it sounds good in theory, but in practice, the amount of processing power that a lot of systems have is way and above, far and above what they actually need to do their transaction processing. In fact, we've seen cases of data warehousing systems being implemented on the same physical machine, separate system, but same physical machine as their transaction processing system. Completely defeats the purpose of avoiding query drain. And for a long time, that was the key message that vendors had. Protect your whole TV systems. Everyone say hi to Steve.
Hi, Steve. Hi, Steve.
Steve's going to be one of our tutors this semester. So he's come back from... did you have a class or... You just run my units. It's an easy start to a Monday for Steve. So.
I'll swap an ID.
Ah, yes, you had industrial experience students. So, yeah, you know that stuff about data warehouse failure that I mentioned earlier? For those of you in Steve's tube, hassling about it later. He's got great war stories. So, query drain sounds good from the vendors, but really in practice... efficient data retrieval. I've seen lots of data warehouses designed using the same design approaches as transaction processing systems. Fully normalised, atomic data structures. They're not really designing for efficient data retrieval there. They're designing for, instead, ubiquitous application of that data. So if you've got a normalised data structure, it's actually quite flexible to be able to use for different kinds of business applications. Whereas as soon as you start integrating data into a subject-oriented perspective, you're assuming a certain usage of that data. So it becomes less universal. So there is a very strong school of thought that says you should have a completely normalised data warehouse, and that mapping that I talked about a second ago, creating that subject-oriented perspective, this is the way to go because it makes your data warehouse much more flexible down the track. There's a lot of debate about that. I tend to be of the school of thought that the subject-oriented type approach for the data warehouse is better, but I've seen both quite successful. Steve, you've seen...
It's beyond debate, it's more, this sort of rivals most religious wars.
Yeah,
I've been to conferences and actually get to the point where people have nearly come to blows over which opinion is better than the other.
Exactly. So remember the guy I talked about before, Bill Inmon and Richard Hackathorn, the guys who wrote that quote about subject-oriented and so on. Bill Inmon was kind of the leader of the camp of the large-scale data warehouse designed using normalised data structures. Ralph Kimball, who is the author of those recommended texts that I mentioned a second ago, some of you may have heard of Ralph Kimball. He's kind of the leader of the camp of the, no, we must do these subject-oriented type data structures. So you've got your Immonites and you've got Kimball-ites, and it's like, yeah, different Semitic tribes. They just go to war with each other. Yeah, it becomes ideological. Often there's no rationality to the debate. It's just my way's the right way. God damn it. Okay, so each of these dot points have a larger or stronger argument or lesser argument. But really, I think in many cases it boils down to this last dot point. It allows organisations to remain competitive because it gets organisations thinking about how is our business working, where can we improve things, what do we need to fix, and keeping an eye on the performance of the organisation so that when a problem occurs, you can respond to it quickly. That's really the key thing. We're running out of time, so I'm going to skip forward a little bit. I've got to mention the one version of the truth thing. This is, again, another fantastic marketing term used by most of the vendors, particularly Microsoft and Teradata and so on. The idea being that if you've got a data warehouse, you've got one source of data that managers can then call on when they make decisions. A classic problem when you're trying to make a decision in an organisation, you call a meeting and all the relevant managers come along and try to solve a decision problem. They come up with their own reports and their own analysis of the numbers, and the numbers don't match up. So you've got one manager who says, oh, the situation is this, another manager who says, oh, no, the situation is this. And the reason is not because their analysis is faulty, but because they've made slightly different assumptions and done the analysis in slightly different ways, and so they've come up with different numbers. The advantage of a data warehouse is that if everyone's using the same source data, then you're going to minimise those discrepancies of what the real situation actually is. So this mantra of build a data warehouse and you'll have this one version of the truth in the organisation becomes a really strong selling point. No longer will there be disagreement about how the organisation is performing. How many times have you seen that actually work, Steve? Would be a number approaching something very round.
Well, the thing that it's great theory, but getting to it is often getting to the one source of the truth is often impossible. Very quick, I had 7 senior executives of a very large insurance company from Queensland, which is now very, very busy from recent activities. I hate to be there at the moment, it's awful. They had 7 very, very different interpretations of gross profit.
I feel like
Because
fundamental concept.
Yeah, because they all came from different parts of the business. There was the claims manager, the new business manager, the finance manager, and they all saw the term gross profit from their specific perspective.
That's right.
So how do you get? And this was an enlightening concept. They went, oh, you mean you calculated that? Oh, well, we calculated. They didn't realise that every different part of the business calculated gross profit in a different way.
So this creates 2 problems. One is getting that one version of the truth out of the system. Remember that diagram I had? The data warehouse only sits in the middle there. So there's people are still using these analytical systems, designing these systems and doing analysis based on the assumptions that they've got. So users of this system might calculate gross profit quite differently to users of another system, even though it comes from the same data warehouse. But designing the data warehouse for that one version of the truth, imagine you put in a field of gross profit in the data warehouse. Do you think you could get all the users to agree on what that number should be? How the ETL process should come up with that gross profit figure? Not a chance. So what we often see is, A, organisations don't have one single data warehouse, therefore no one version of the truth. And even when they do, the numbers that they pull out and start analysing leads to divergence of truth anyway. So it's a pipe dream. It's a
That's very interpretivist.
yes, it's not objectivist. It's very interpretivist. So this one version of the truth became a great selling point. The vendors all said, became a spiel that they always trotted out for 5, 10 years was the main selling point. Just doesn't happen. What data warehouses do provide an opportunity for, though, is the official version of the truth. So it may not be the one version of the truth, but it's the version that everyone's kind of grudgingly agreed, okay, this will be the data of record. This will be the official version that we'll use for annual reports and things like that. So it's not one version of the truth, but it's just we'll agree to disagree kind of thing in the organisation. And that in itself can actually be quite a useful thing to have. Data quality, we've talked about data quality, so I'm going to move on. I've talked about how complex it is, so I'm going to move on again. We'll come back to this in week 8, I think, 8 or 9. So I'm skipping over it, but we will return. Just remember, data quality, major problem for organisations, and it's harder to fix than it first seems. Okay, this is a diagram which some of you may have come across before, or some of you doing 5094 this semester will definitely come across it in the next couple of weeks or so. This neatly summarises that point I was making earlier, that the use of a decision support tool, a business intelligence tool, has this chicken and egg problem. You can't build the system until you've got the requirements, but you don't get the requirements until people start using the system. And this diagram was drawn up by a guy called Peter Keene in 1980, who was trying to describe what were then called decision support systems, but really in a generic sense refer to any kind of IT system designed to support decision making in an organisation. And the key insight was the idea that a systems development process consists of users, the system being developed, and the team building the system. So users, system, and builder. And in a DSS, there's a two-way interaction between the user and the system. As the user uses the system, they learn about the decision problem, they gain insight into the decision problem, and that changes their information requirements. That then means that the design requirements for the system change too. The design requirements for the system being driven by the information requirements of the users. So because this is a two-way loop with a decision support tool, you've got this problem of changing requirements over time, and it becomes a cyclical process. Question, answer, question, answer, question, answer, and the system has to evolve to keep up with those changing requirements. Now you can design the system as flexibly as possible to minimise the number of sort of changes that you need to make to the system. But at some stage you're going to get to the point where people are asking questions that the system simply can't answer, and you have to change the design of the system. So this is Peter Keene use this as a key argument to say, look, the waterfall model of the SDLC just doesn't work for decision support systems. And because the framework applies to any kind of IT used in the decision-making setting, the waterfall model, the traditional approach to the SDLC, just doesn't work for BI. And by extension, becomes difficult to work for data warehousing as well. So we instead need an evolutionary development methodology, one that perhaps deploys an initial prototype system based on a sketchy understanding of what the requirements might be, getting some feedback from the users and redesigning the system, letting the users use the system, getting some more feedback and so on, and it becomes a cyclical, iterative, evolutionary development process. Very different to the traditional linear waterfall model of the SDLC. And it all comes back from Peter King paper in 1980. Now, if you're doing 5094, you'll read that paper. That's one of the assigned readings in 5094. Might have been, has anyone done 5093 yet?
Yeah, it's part of 593.
This was discussed in 5093. So if you're doing 5093, you'll read about this again. If you're doing 5094, you'll certainly read about it. But if you're not doing either of those units, hunt down the Keen paper, Keen 1980. It's in a journal called Data Space Base. Easy to read, not particularly long, and really does describe in a nutshell why the systems development process for data warehousing and business intelligence is different to designing and implementing OLTP systems.
It's a bit of a Ten Commandments-y type of thing in decision support systems and BI and data warehousing.
Yeah.
Many practitioners will say, oh, you've got to have an evolutionary design, but they don't really understand why.
Yep.
That document explains why.
There's very few fundamental theories in IT. We're a fairly pragmatic applied discipline, but this is one of those theories. So it's really good to wrap your mind around. It's like, the theory of relativity in physics. It explains the fundamental difference of why these systems have to be designed in a particular way.
What was the name of the article?
Can't remember. Framework for... Can't remember. Do a search for Keen 1980. Peter Keen 1980.
Come on, hurry. That's the
There
one
we go.
Design.
Adaptive design for decision support systems. Oh yeah, it's in the... I said it as a read. Next week. So it'll be available on Moodle.
You've just forgotten.
I know. So it'll be available via Moodle, and in fact, it's probably available now. Yeah. So go read it. It's a short paper. It's good, and it's a classic piece of IT theory.
It's a classic.
It literally is. There's few classics in IT. This is one of them. So this is that dynamic that's at the core of the use of any kind of decision support system described by Peter Keen. Users use the system, changes their understanding of the problem, that changes their requirements, therefore the system has to change, and then the cycle repeats. So rinse, lather, repeat. Okay, so how are we doing time-wise? I've got the brand new version of PowerPoint and it's changed the display. So the information that used to be here is saying you've got 5 slides to go. It's now top right corner. We've got 10 slides to go. We may not get through all the material. In fact, we're not going to get through it. There's the survey material that I was hoping to get to this week. We'll do that next week. So let's just push on with the sort of fundamental differences with data warehousing. Data warehouses, as I said, with this unit, we're looking at data warehousing not so much as a technical artifact, a thing that gets built, but treating data warehousing as a process that uses technology, but it's a process of taking information from source systems, transforming it and delivering it to end users to improve decision making. And particularly decision making, but that entire process is actually quite a dynamic kind of process. And we're going to look at this in more detail next week. But the kinds of dynamic processes that lead to changes in requirements are the fact that our decision makers, our users, are in many cases coming up against novel decisions they haven't faced before, or decisions which are faced on an irregular basis. So there's no one right answer to the decision problem. There might be high levels of ambiguity in terms of what information do I need, what do I need to understand to be able to make a good decision. There might be political influences as well. So as a manager, I might be thinking of going down one route, but that's going to disadvantage certain groups in the organisation. So I did something that annoyed those people last time, so I'm actually going to do something slightly different to keep them happy. So piss off another group instead and balance things out. So political things become a real issue in terms of the decision-making process, and that then impacts the flow of decision that you go through. and therefore the information requirements from a data warehouse. So novel decision problems lead to ambiguity in terms of information requirement and lead, as a consequence, often to unanticipated uses of the system. And that's, again, something that came out of Peter Keen's work, that classic paper. Regardless of how well you've designed the system, how tightly you think you've captured the information requirements, A, those information requirements are going to change, and B, you can't predict exactly how people are going to use the system. You're going to find that people are going to use the system in very creative, unanticipated kinds of ways. And if you're not keeping track of how people are using the system, then you're going to miss out on an opportunity to facilitate those creative, unanticipated uses to make them more directly supported by the system. So the users are always stretching the boundaries, stretching the envelope of what the system can do to try to answer the questions that they've got. And if you as a developer are not keeping track of those tensions, then you can't redesign the system to make the resolution of those requirements easier for the end users. And that's really what we're trying to achieve.
The other part of that comes back to when you're designing your system, like this is where developers of traditional transactional systems get stuck because the requirements are carved in stone. We can have our invoicing system, we do it, and that's the way it's going to be, and that's the way it's going to stay.
Yep.
You have to architect your system before you even build it.
Did you just use architect as a verb?
Well, it's never going to incentivise.
Yes. Goal your users, yeah.
So that flexibility is possible. A lot of systems are created in such a way that they just do their job and that's the only job they do. A data warehouse has to be designed in such a way that it's easy to make changes, it's easy to add things in. And often that's not done.
Yeah, in some ways, the transaction processing system shaped the organisation rather than the other way around. So, has anyone deployed SAP or another ERP system in their organisation? Well, yes. We've done it here at Monash, and it completely changed the way Monash does its administration. So, it's kind of industry best practice, industry common practice perhaps. But SAP changed Monash. But in theory, it should be, if you're deploying an ERP system, let's design the system to meet the way Monash does the thing, or used to do the things it used to do. So with OLTP systems, you often find the organisation changes to match the package that gets installed. You just can't do that with BI and data warehousing. The users are discretionary. They're managers. If they don't want to use the system, they're not going to use it. Whereas OLTP system users, the lowly checkout clerk at the supermarket doesn't like the checkout system, well, they can choose not to work, but they have to use the system. Senior manager, if they don't like the BI system, well, they'll get their information some other way. They're discretionary, they're organisationally powerful. So you can't mould their practice to the system in the same way that you can with OLTP systems. So changing business requirements, changing decision requirements, and even changing technical environments. You change one source system, that means you've got to update your data warehouse, the ETL process. There's a flow-on effect to every single technical change at the source layer through to the delivery system. So all of these things lead to a chaotic development environment for data warehousing that you just often don't get with enterprise OLTP transaction processing type systems. Oh, I think we're about to be given the shuffle on. So a couple of key issues that we're going to cover. Project management, data quality, managing users and governance. So we're going to cover those in the next next 12 weeks or so. And next week we're going to look at this now actually quite old research, but the findings are still relevant. Looking at the Australian data warehousing industry, just to give you a feel for what's happening in the industry at the moment. But this is kind of where we're headed.
We do.
Okay, any questions before I let you go? No? Okay, don't forget tutorials do start this week. So for some of you, the tutes start in about 10 minutes. But for the rest of you, it's sort of later in the day or tomorrow. See you guys later.
I had an interesting question while you were talking to the lecture. Has anyone tried to implement data warehousing on the cloud? Because that would...
Data warehouse kind of by definition is in the cloud. because it's a network thing. So
Yes, but what if you actually use somebody's cloud, so you don't actually care about the resources it takes to run certain reports that might take a longer time on your cloud, but if you pass it on to Google or Amazon?
Yeah, it has been done a little. There's been a little playing around it, but because of the volume of the data and the sensitivity of the data, organisations are often very sensitive about letting that go outside of the organisation.
They're actually very secure. They
may be, but there's still a third party managing your data. So A, the organisation can go out of business, or B, maybe you're competing with the cloud service provider, or there's all sorts of
political things.
Yeah, so it's been toyed with, but it hasn't really, not a huge amount of uptake.
All right.
Okay, which tube? There's actually three. Okay, well, that'll be my tube. So, come on. Do you have a tutorial number that is for you?
I've read the instruction.
I just want to know if it's going to be the first one. Well, like I said, there's 3 tubes running simultaneously. And there is definitely one in B345, but there might be one in the other one as well. So, hang on, let me pull up the web browser and pull up Elevate Plus. See where we go.